Welcome to AI Frontiers, your gateway to the cutting-edge developments in artificial intelligence and information retrieval. Today, we're diving into the fascinating world of computing science information retrieval, or cs.IR for short. Information retrieval is a critical subfield of computer science that focuses on the acquisition, organization, storage, retrieval, and distribution of information. It's the backbone of modern search engines, recommendation systems, and many other applications that help us navigate the vast sea of data in the digital age. In our analysis of recent archive preprint server papers, several dominant research themes emerge. To set the stage, let's explore what information retrieval, or IR, is all about. IR is essentially the science of searching for information in documents, databases, or even the web. It's about finding the needle in the haystack. This podcast will dive into the latest developments in information retrieval, explore key research themes and methodologies, highlight groundbreaking findings and their implications, and discuss future directions and challenges in the field. Information retrieval is the science of searching for information. It is essential for search engines, recommendation systems, and more. IR focuses on acquiring, organizing, storing, retrieving, and distributing information. This is critical for navigating the vast sea of digital data. Whether you're searching for a specific document, a relevant product, or a piece of information, IR systems are designed to sift through enormous amounts of data to deliver what you need. The significance of IR cannot be overstated. A key theme emerging is the development of retrieval models for multilingual and low-resource language retrieval. One influential study by Keedist Amde-McConnell and her colleagues has introduced optimized text embedding models for Amharic, a morphologically rich language with limited data resources. Their work highlights the challenges and opportunities in adapting retrieval systems to languages that are often overlooked in mainstream research. Another prominent theme is multimodal information retrieval, which combines textual and visual information to improve retrieval effectiveness. Zuri Lee and his team have developed DocMMIR, a framework that unifies diverse document formats like Wikipedia articles, scientific papers, and presentation slides. This multimodal approach promises to enhance the accuracy and relevance of retrieved information by leveraging both textual and visual cues. Synthetic data generation is gaining traction as a way to overcome the limitations of labeled data. João Coelho and his team have proposed a framework that uses direct preference optimization to generate high-quality synthetic queries. This approach not only reduces the need for costly labeled data, but also improves the overall performance of retrieval systems. Efficiency is a key concern in recommendation systems, especially as they scale to accommodate millions of users and items. Zhuram Liang and his colleagues have introduced lightweight embeddings with rewired graph for collaborative filtering, or LERG. This method reduces the storage and computational costs associated with graph-based recommendation systems, making them more suitable for deployment on resource-constrained edge devices. Key findings in the field include breakthroughs in Amharic passage retrieval by McConnell et al., significant enhancements in multimodal document retrieval by Lee et al., and the demonstrated effectiveness of synthetic data generation for web search by Coelho et al. Additionally, Liang et al. Have improved the efficiency of recommendation systems, and Liu et al. Have optimized query decomposition for better retrieval performance. Several common techniques are emerging as key tools in the information retrieval toolkit. Pre-trained language models like BERT and Roberta are widely used in information retrieval. These models are trained on large corpora of text and can be fine-tuned for specific retrieval tasks. Their strength lies in their ability to capture complex linguistic patterns and semantic meanings. However, they require substantial computational resources and can be challenging to adapt to low-resource languages. Multimodal fusion techniques combine textual and visual information to improve retrieval effectiveness. These methods leverage the complementary strengths of different modalities to enhance the accuracy and relevance of retrieved information. However, they can be complex to implement and require high-quality multimodal data, which may not always be available. Kiristamde Mekanen and her colleagues set out to address the challenges of low-resource, morphologically rich languages like Amharic in information retrieval. Their goal was to develop optimized text embedding models that could improve the effectiveness of passage retrieval in Amharic. The team introduced Amharic-specific dense retrieval models based on pre-trained Amharic BERT and Roberta backbones. They evaluated these models against both sparse and dense retrieval baselines to assess their retrieval effectiveness. Ziri Li and his team aim to address the limitations of existing multimodal information retrieval studies, which lack a comprehensive exploration of document-level retrieval. Their goal was to develop a framework that could unify diverse document formats and domains within a comprehensive retrieval scenario. The team introduced DocMMIR, a novel multimodal document retrieval framework that integrates textual and visual information. João Coelho and his colleagues sought to address the challenges of training neural retrieval models with limited labeled query document pairs. Their goal was to develop a framework that could generate high-quality synthetic queries to improve downstream retrieval performance. The team proposed a framework that leverages direct preference optimization, DPO, to integrate ranking signals into the query generation process. The field of information retrieval is making significant strides, with groundbreaking research addressing the challenges of multilingual and low-resource language retrieval. Multimodal information retrieval, synthetic data generation, efficient recommendation systems, advanced query decomposition, and cross-domain recommendation. These advances are pushing the boundaries of what is possible in information retrieval, making it more effective, efficient, and accessible. However, there are still many challenges to overcome. This synthesis was created using AI tools including GPT Mistral, using model mistral-large-latest, TTS synthesis using openai, and image generation using grok. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided in the content. Thank you for joining us on this journey through the frontiers of information retrieval. Subscribe to our YouTube channel for more exciting developments in AI and information retrieval. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.